Hello guys. Yes, Nana. One of you have asked a question, a doubt from page number 181. Vidyashri, are you there? Ping a message, Nana. Ping me once. Yeah. So the questions are belongs to lenses. Lenses part. Yeah. The question number 49. 49. Page number. Page number 181. Right. The question is a concave lens, a concave lens of glass of refractive index 1.5 has both surfaces of same radius of curvature. Concave lens of glass have refractive index 1.5. Concave lens, concave, not convex, concave lens have both surfaces both surfaces of same radius of curvature. Means R1 is equal to R2 is equal to R. On immersion, on immersion in a medium of refractive index 1.75, in a medium refractive index of a medium, let us say it is immersed in a when it is in when it is in air. Okay, this is the refractive index of glass with respect to air. When it is in a medium, then refractive index uh, uh, it is immersed in a medium, so the refractive index of the medium with respect to air is 1.75. Okay, then it will behave as what kind of lens when it is in a medium of refractive index 1.75. What kind of lens it will behave as? If it is air, the air will act as radial medium. The material of the glass may have denser, will behave as a denser medium. Okay, but if it is immersed in a medium whose refractive index is more than the refractive index of the material of the lens, then this will act as a radial medium. This will act as denser medium. That you have to understand. Just with sign if you take and if you simplify. Then actually uh, here I have to say one second 1 by R1 minus 1 by R2, right? The R values we have to take especially this is R2 is positive. Okay, yeah, let us see. This is minus 2 by R. So you can take it as 0.5 into 2 is 1. So it is equal to minus 1 by R. Minus 1 by R is 1 by F. Okay. Whereas when it is immersed in a liquid, what kind of lens it acts like? Of course, because when it is in air, it will act like a diverging lens. So it is a focal length is negative means it will act like a diverging lens. But when it is in a medium, then what kind of lens it will behave as? 1 by F is equal to mu minus 1. The here mu of glass with respect to medium. So mu of glass by mu of medium minus 1 into 1 by R1 minus 1 by, of course it is minus 2 by R only. But what about this? We have to take, it is this mu of glass with respect to air is 1.5. Mu of medium with respect to air is 1.75. 1.75 minus 1 into, it is minus 2 by R. Here if you observe, this is 1.5 minus 1.75, negative term is larger. So you can say 1.5 minus 1.75 is 0.25 minus 0.25 minus 0.25 by 1.75 into minus 2 by R. Here minus into minus becomes plus. So obviously you can understand that the focal length will be positive. For positive means the combination with the concave lens inside in a medium of refractive index of this will have a will behave like a lens with positive focal length means converging lens it will act like. So options were either 1 by 1 or 2. But with what focal length, if you can find out, then it will give you clarity. So if you can write it as plus. So 25 by 175 you can write 25 by 175 into 2 by r. So it will be 25 into 2 is 50, or you can write like 25 into 2 by 175 into r, 175 r. So here 25, how many times it will goes? 3 plus 4, 7 times, right? 7 times. So it is equal to 2 by 7r. 1 by f is equal to. So from this you can say f is equal to 7r by 2, or it is equal to 3.5r. So option 1 is correct. It is from this we can understand that it is having positive focal length, means it has to behave like a converging lens of focal length 3.5r. So option 1 is the right one. Okay. Next, question number 50. So is also asked about question number 50. Question number 50. 181. The question is, a thin convex lens is made of a thin glass of refractive index 1.5. Thin convex lens. Thin convex lens is made of glass of refractive index mu is equal to 1.5, refractive index of glass, and its focal length is f is equal to 0.2 meters. If it acts as a concave lens of 0.5 meters focal length, let us say f dash is equal to 0.5 meter focal length, when dipped in a liquid, then the refractive index of the liquid is when it is in air, the focal length is this. When it is in a liquid, then focal length becomes this. Provided what should be the refractive index of the liquid is the question. Same, you have to apply what is that Lensmaker's formula. According to Lensmaker's formula, first, if you apply Lensmaker's formula for first case, 1 by f is equal to mu minus 1 into 1 by, you can consider 1 by f dash is equal to, when it is immersed in a liquid, here the refractive index of glass with respect to air, the refractive index of glass means with respect to air. Here, when it is surrounded by liquid, then you have to take refractive index of glass with respect to liquid. That means you can take it as refractive index of glass by refractive index of liquid minus 1 into 1 by r1 minus 1 by r2. So if you take this is 1, this is 2. We have given focal lengths in both the cases, first case and second case. And radii of curvature values are not. If you observe here how to find, if you just think about this kind of questions, whenever you come across, you have to divide this, then it is easy to find out. So let us take 1 by 2, 1 divided by 2, 1 divided by 2 gives 1 by f divided by 1 by f dash, 1 by f dash goes to numerator, so f dash by f is equal to mu g minus 1, directly also you can substitute the values. Here 1 by 2, this by this, 1 by r1 minus 1 by r2, 1 by r1 minus 1 by r2 gets cancelled, so mu g minus 1 by this will get, so you can write it as mu g is 1.5, 1.5 minus 1 is 0.5. You can take this as it is, mu g by mu l minus 1, and here you can substitute the values of f dash and f also. F dash is 0.5 by f is 0.2 is equal to 0.5 by mu g by mu l minus 1. 0.5 gets cancelled, then you can write this is equal to this, or mu g by mu l minus 1 is equal to 0.2, or this is equal to 0.2 plus 1, so it becomes 1.2. So mu l is equal to mu g by 1.2, or mu g is 1.5 by 1.2, so it is 15 by 12. So if you multiply, if you cancel with 3 fives, 3 fours, 3 fives, 3 fours. So it is mu l. Options they have given. Uh, focal length of the refractive index of the liquid. Did we do this properly? Mu g by mu l, mu g by mu l minus 1 is the values I have taken properly. 1.5, 1.5. What is this? Wait a second here. Focal length. Focal length 0.2. So thin convex lens of made of refractive index 1.5 and its focal length 0.2. F is 0.2. F is 0.2. And it is immersed in liquid. It will behave like a concave lens of focal length 0.5. 0.5 meters. 0.5. F dash is 0.5. 0.5 by 0.2 is equal to here mu g minus 1. Mu g is 1.5 minus 1 becomes 0.5. So 0.5 by mu g by mu l minus 1. So 0.5, 0.5 cancel. So you can say this is equal to this. Mu g by mu l minus 1 is equal to 0.2. So if you send that side becomes plus 1. So 1.2. Mu l is equal to this 1.5 by 1.2. 5 by 4. Yeah. So but in the options, question number, if you see the options, 15 by 8 is there. 15 by 8. Can you say 15 by 8? 15 by 8. We'll check the calculations. 15 by 8 is given in the option. 8 is it 0.8? It becomes minus 1. 1 minus 0.2. So if you take this mu g by mu l minus 1. Sign convention, these are the sign conventions properly. A thin equiconvex lens made of equiconvex lens. Equiconvex means R1 R2 are equal. So it should be 2 by R, 2 by R. When it is immersed in a liquid, it behaves like a concave lens. Yeah. So here you should have taken this as a negative. You should have taken this as negative guys. F is positive, F is 0.2, F dash should be, it is a concave lens, so it should be minus 0.5, minus. So you get, this is, if it goes that side, you'll get minus sign will be here, minus 0.2, minus 0.2 plus 1. So it will give you 0.8. This is not 1.2, this will be 0.8, 0.8, or you can write it as 15 by 8. A small correction here, should be 15 by 8. Sorry, 15 by 8, not 18. 15 by 8, 15 by 8. So mu L, refractive index of liquid is 15 by 8. So why it is? You have should take the this refractive focal length of the lens in a medium. This is a concave lens of focal length. Concave means with the sign convention, if you take focal length will be negative. So f dash should be negative, minus 0.5. So minus will get here. So minus of this is equal to 0.2, or this mu g by mu l minus 1 is equal to minus 0.2. So then you will get minus 0.2 plus 1. So plus 0.8 you will get. Okay. This here you have to take little care. A plano-convex lens of thickness 4 centimeter. A plano-convex lens. A plano-convex lens. A thickness of 4 centimeter, having a thickness of 4 centimeters. Its radius of curvature is 20 centimeters. Plano-convex lens. Okay. Its radius of curvature is r is equal to thickness is 4 centimeter and radius of curvature r is equal to 20 centimeters. When its curved surface is kept on the horizontal surface and viewed from top, its bottom appears to be raised by 1 centimeter. That means it is a normal shift. You will see that. Have a plane or convex lens. This convex surface, curved surface is kept on horizontal surface like this. Like this. Like this. This is a plane or convex surface is kept on a horizontal surface. Like this. So thickness of this is means of from here to here, this thickness. This is the thickness. This thickness is given as 4 centimeters. That means from here to here. From here to here. Thickness, this is called as thickness. T is given as 4 centimeters. And of course, radius of curvature of R2. 1 by R1 minus 1 by R2. So focal length of this surface will be negative. So minus of minus will be positive. For the first surface is infinity. So we get mu minus 1 into 1 by R. 1 by R. R is given. If you know mu, you can find out. So how to find mu? So you can find mu by using one relation that here normal shift upper end depth. This is called as the thickness can be also called as real depth. Real depth. So you should know that. But if you see from here, it appearing like this. The bottom is appear to be here. So this distance will be called as upper end depth. Upper end depth. So you should have to express it as real depth is equal to upper end depth plus normal shift. Depth from this is equal to real depth minus normal shift. Real depth is nothing but thickness. Real depth is nothing but thickness. Thickness T. Normal shift is given directly. Thickness also is given directly. Upper end depth. Upper end depth can be expressed as real depth by mu. Real depth by mu. So from this we can write mu is equal to, by cross multiplying, real depth by T minus ns. Real depth is nothing but T. So you can also write it as T by T minus ns. T minus ns. So from this mu is equal to T is 4 centimeters. It is equal to 4 centimeters. 4 by 4 minus ns is 1. 4 minus 1 it is equal to 4 by 3 is mu. That's going to find focal length. So 1 by f is equal to mu is how much? 4 by 3. 4 by 3 minus 1 is 4 minus 3 by 3. So it is 1 by 3. 1 by 3 into for planar convex lens. R1 is infinity, R2 is minus R. So it is 1 by R. 1 by R. It is equal to 1 by 3. 1 by 3R. 1 by f is equal to 1 by 3R. F is equal to 3R. Is equal to 3 into R is 20. So it is equal to 60 centimeters. 60 centimeters. 53. Right.